Hello, students, and welcome to our lesson for the free response practice exam questions number 1. We are going to start here with problem 1. And for these problems, I'm going to show you the work that I did, and then I'm also going to show you the grading scale used on the College Board when these problems are graded. So just to give you a little background here, how this works. Now your test would be a little different, but the free response questions will be formatted the same, and they will be graded the same as the years past. So even though the formatting may be different as far as the length of the questions, the number of questions, um, the way the questions are asked and the way they're graded will be very similar to the past. So I want to let you become familiar with these a little bit. Um, there's 6 free response questions total on previous exams. Um, to with a calculator for 30 minutes, 4 without a calculator for 15 minutes. So you're expected to take about 15 minutes per problem working on them. So as far as the length of time, you're going to have one 25-minute problem and one 15-minute problem. So you can expect one problem to be about the same length as one of these. The first problem to be a little bit longer than one of these, your 25-minute problem. Okay, so I wanted you to become familiar with uh, how to answer the questions and how that's scored, what they're looking for as far as what earns you your points, because that's what we want to really make sure you show. Not only do you know how to solve the problem, but can you earn the points that you're supposed to get? So, question 1, this one is with a calculator, and your calculator was necessary for some of these, as you saw. Um, Grass clippings are entering a bin. They decompose. This is the amount of grass clippings at time t. Find the average rate of change of the interval 0 to 30. Okay, so average rate of change is just the slope. All right, just your regular algebra definition. Change y would change in x, and there you go. And it said indicate units of measure, so make sure you put pounds per day. Remember, anytime you're finding units for a slope, it's just units of the numerator over units of the denominator. So it's pounds per day. All right. B, find a prime of 15. Now remember, this is a calculator question, so you don't have to do the derivative by hand. You can use the derivative feature on the calculator and interpret the meaning in the context of the problem. So in the calculator, a prime of 15 is negative 0.0164. Okay. And what does that mean? Um, a is the amount of grass clippings. So anytime you're interpreting derivative, just say the rate of change. The rate of change of the amount of grass clippings is negative 0.0164 pounds per day when t equals 15. Okay, make sure you say that t equals 15. You must say whatever x value is. Now, this isn't the only way you could say it. You could say the amount of grass clippings is decreasing by 0.164 pounds per day when t is 15. Since it's negative, it's increasing. If it was positive, you could say increasing. Either of those are correct, but you can always just say the generic rate of change, and that works too. All right. Part C, find the time when the grass clippings is equal to average amount of grass clippings from 0 to 30. So you had to basically do two things. First, find the average amount of grass clippings from 0 to 30. And that's a formula you need to know. 1 over b minus a integral a to b of a. And you can do that in the calculator and get 82.579. All right. So that's the first part. And then the second part was find when a of t is equal to that. So we set that equal, and once again, just solve that by graphing on your calculator, and you get about 12.415. And then D, uh, the linear approximation to a at t equals 30 is a better model for the amount remaining. Use L to predict when there'll be 0.5 pounds of grass. Okay, so I think the L of t confused some students, but when you see linear approximation, remember that's just tangent line. All you have to do is write equation of a tangent line. The L of t is just what they want you to call the tangent line, okay? But that didn't really matter. So tangent line, we need two things, right? We need a point and a slope, okay? So a of 30 is the point, a prime of 30 is the slope. So you have your point and your slope, and then you can find the equation of the tangent line, and there you go. There's your linear approximation. Um, and then you can call it L of t. You don't have to. You don't have to call it L of t as long as you had a tangent line. That was the point. And then the second part, you want to set this equal to 0.5. They said find how long for the amount of grass clippings to be equal to 0.5. So set that linear approximation equal to 0.5 and algebraically solve for t. You get 35.054. Okay, so there was 9 total points on that. And now I want to show you the scoring guidelines. Okay. Now this has the answers on the side as well, but um, the way they have it written out isn't necessarily the way that I would write it. There's not really any work shown there. So I wanted to show my works to help give you a better idea how I solved it. Okay. So, but this is the official answer. What's important on the side is you can see how many points each part is worth. So I want to break it down so you can score yourself and see how many points you would have got. Okay. So part A was just 1 point. Answer with units. Notice if you had the answer without the units, you got 0 points. There's no half credit. You need the answer with the units. Okay. Part B, 2 points, 1 point for the derivative, and then 1 point for the interpretation. Okay, and again, the interpretation had to say something about the rate of change, or the rate is decreasing or decreasing at that rate, something like that. And again, make sure you say t equals 15. C, 2 points, 1 point for showing the average value formula, and then 1 point for the answer. Okay, notice you didn't even have to find this correctly. As long as you showed this formula in some way, shape, or form, that was a point, and then 1 point for the answer. And then D was 4 points. Okay, 2 points for the tangent line. Okay, and the way that usually works is usually 1 point for the slope, and then 1 point for the whole tangent line, something like that. So 2 points for the tangent line. And then 1 point for setting that equal to 0.5, not even solving it, just setting equal to 0.5 is the third point, and the fourth point was the answer. So this is one of those, even if you didn't get all 4 points, hopefully you got at least the first 2 points on the tangent line, okay? So that was 9 points on that problem. All right, now on to problem number 2. Actually, I'm sorry, we skipped 2. So never mind. Let's go right to problem 3. Okay, wait a moment for the screen to clear. Sorry, let me find my work here. It gives you a graph of f, defines g as the integral from -3 to x f of t, find g of 3. Okay, pretty straightforward there. G of 3 is just the integral from -3 to 3, so just find the area under that curve, top minus bottom, from -3 to 3, and you get 9. Okay. B, over what intervals is the graph of g both increasing and concave down? So if g is the integral of f, then f is the derivative of g. And that's very important you show that. You need to, somewhere in your answer, say that f is g prime, okay? Or even on the graph, if like here you can put f equals g prime right there. But somewhere you had to indicate the relationship between, to show that f is the derivative of g. And then in your reasoning, we know g is increasing when its derivative is positive and concave down when the second derivative is negative. So the two intervals would be -5 to 3 and 0 to 2, because we want the graph to be positive but have a negative slope. Positive but have a negative slope. So -5 to 3 and 0 to 2. And you had to say because g prime was positive but also decreasing, which means that its slope or its derivative was negative. So that's what I wanted for part B. Part C, just take the derivative. It defines a function h of x as g of x over 5x. Find the derivative and then plug in 3. Okay, so first thing, find the derivative. Just do the quotient rule. And then second step, plug in 3 for x. And so v du minus u dv over v squared, and then plug in 3, that's 15 times g prime of 3 minus 5 times g of 3 over 15 squared. Okay, or 25 times 3 squared if you wrote that as 25x squared. Okay, whatever. However you do it. Now, back to this. How do you find g of 3 and g prime of 3? Well, that's from the graph. That's from the graph. Remember, this is the graph of g prime. So just go to 3, and the y value here is -2. That's where I got that. And g of 3 was your answer from part A. Just plug in 9 there. Okay. And then just simplify, you get -75 over 225, or -1/3. By the way, remember, you don't have to simplify. If you stopped right here, that would be a correct answer. That'd be the full points. Or you could do here, or you could go to here. Those are all correct. But you can stop here and still get the full points. I just want to be clear on that. So you don't need to simplify arithmetic if you don't want to. And lastly, D, it gives you another function, p of x as f of x squared minus x. Find the slope of the tangent line at -1, which once again just means find the derivative. This time you have to use the chain rule. right? So just write out your work. Make sure you're showing your work here. It's f prime, derivative of the outside, inside stays the same, times the derivative of the inside. Now plug in -1. So it's just going to be f prime of 2 times -3. And once again, get f prime from the graph. Now this is the graph of f. So f prime is the slope. Go to 2. What's the slope of this line? Slope of this line is -2. That's where that -2 comes from. And you get an answer of 6. All right, so let's look at the scoring guideline for this problem. Part A was just 1 point. As you can see, pretty simple there. There was 1 point. Part B was 2 points. 1 point for the answer and 1 point for the reason. So 1 point for giving the answers, the intervals, 1 point for the reason, uh, saying that G is both positive and decreasing, or positive with a negative slope, anything like that. You can make sure you're reasoning. You have to indicate how F and G relate like that. C was worth 3 points. 2 points for the derivative. So just doing the derivative without simplifying and plugging anything in was 2 points for doing the correct quotient rule. And then the third point came for plugging the numbers and getting an answer of -1/3. Or again, you could have stopped there. That was 3 points right there. D was also 3 points. Once again, 2 points for the derivative using the chain rule correctly, and then 1 point for the answer. So even if, what I want to show you, just to make sure you recognize here, even if you made an arithmetic mistake, as long as you did the derivative correctly, you got most of the points. You got 2 out of the 3 points. Okay, so there's the 9 points total on that one. Okay, moving on now to question 4. You have a velocity of train A at different time periods given here. And they ask some different questions. Part A, find the average acceleration from the interval from 2 to 8. Okay. Well, average acceleration, pardon me here. Make sure okay, sorry, I said my summary on my computer there. Average acceleration is just the slope of velocity. Notice it's average, so you don't do a derivative, right? You're not doing the slope of acceleration, to be clear. You're doing the slope of the velocity. So you just do v of 8 minus v of 2 over 8 minus 2, and you get -110 over 3. -120, or sorry, -220 over 6, or -110 over 3. Again, you could leave it like this, that's fine. Part B, does the data support the conclusion that the train A's velocity is -100 somewhere between 5 and 8? Okay, as I mentioned before, that's an existence theorem. In this case, the intermediate value theorem. So first thing, you must say that V is continuous. How do I know it's continuous? Because it tells you in the problem V is differentiable. You have to say that. You have to get both points. All right. Since velocity is differentiable, then it must be continuous. And you have to show that the velocity at 5 is 40, velocity at 8 is -120, and the value we want, -100, is between -120 and 40. So because of that, so there is t somewhere between 5 and 8, such that v of t is -100 by the intermediate value theorem. So that's the intermediate value theorem that states that. But by the way, you don't even have to state the words intermediate value theorem. You just have to state the reason why that holds true. Okay, and you'll see in the points here in a moment what I mean about the scoring. Part C, it gives you an initial position, or t equals to the position of 300. Write an expression involving integral to find the position at t equals 12. Use a trapezoid sum of 3 subintervals to approximate that. Okay, so well, first thing I did was I did the trapezoid sum. Okay, and that's just finding the areas from 2 to 12 using 3 trapezoids. So 1, 2, 3. All right, make sure you know the trapezoid formula. That could be asked. All right, so just add those 3 trapezoids and you get -150. That is the displacement from 2 to 12. Integral velocity is displacement. Okay, so to find the position at 12, it's the initial position, or the position at 2 in this case, plus the displacement, integral from 2 to 12. Okay, and this goes back to that fundamental theorem of calculus I mentioned in the multiple choice video, right? F of b equals f of a plus integral from a to b of f prime, right? Since velocity is the derivative position, you're just applying that to a physics problem. So one more time, the position at 12 is the position at 2 plus integral from 2 to 12 of velocity, or the displacement from 2 to 12. So you were given a position at 2 was 300. The displacement is negative 450. So your position at 12 was negative 150. All right, and finally D. Okay, that's our related rates problem. You've got a second train that's traveling north at this velocity. The VA is east to west, so this V is going north. And at t equals 2, that train's 400 meters north of the station. Find the rate at which the distance between train A and B is changing at t equals 2. All right, so here's the picture I drew. Train A is going east, train B is going north, okay? And let's see, what do we know? We know at t equals 2, so d/dt is the velocity of train A, right? It's the rate of change, how fast it's moving. So that's the velocity of train A. And in the table, it tells us that the velocity at 2 is 100. For dB/dt, use the velocity formula given in that problem. Plug 2 in there, and you get 125. And we know at this moment, after 2 hours, we know train A has gone 300 meters. Is it meters, I think? Um, and yes, it's meters. Train B has gone 400 meters, and you can use Pythagorean theorem. That's right. That's a 3, 4, 5 triangle. So the hypotenuse is 500 meters. All right. So that's what we know. So then we set up the equation relating A, B, and C using Pythagorean theorem, and then we take the derivative implicitly. Don't forget your dA/dt, your dB/dt, and your dC/dt. Excuse me. And you can divide by 2 to cancel those out, and then just plug in what you know. You know A, B, and C, you know dA/dt, you know bT/dt, and you just use your algebra to solve for dC/dt. And you get 80,000 over 500, which reduces to 160. So there you go. That's the rate of change of C, is 160. All right, so let's look at the scoring guidelines there. See how many points everything was worth. Part A, as you probably guessed, was just 1 point, because you just find the slope there. Notice it did not ask for units. So even though the scoring guideline gives units, it did not ask for units. You did not have to put that. All right. Just you have to show with these. You have to show the what's called a difference quotient, right? Show the difference and the numerator and denominator and the quotient, and then your answer. That was 1 point. B was 2 points. 1 point for showing that v of 8 is less than negative 100 is less than v of 5. So you had to show that negative 100 was between the value negative at negative 120 and 40, the value at 5, the value at 8. So as long as you show that somehow, that was 1 point. And then the second point is stating the conclusion using the intermediate value theorem. So stating that v was continuous, that comes from that second point. So even if you forgot to state that, as long as you showed this relationship, you at least got one of the 2 points. Okay. C was 3 points. Okay. 1 point for an integral involving showing the position. So showing this integral in some form is 1 point. Okay. 1 point for doing the trapezoidal sum and getting negative 450. And then 1 point for getting the position at 12, getting the final answer of negative 150. Okay. And then D was also 3 points. The whole setting up the Pythagorean theorem and doing the implicit differentiation, that was 2 points. Okay. And then the third point was for getting the answer of 160. So that is how the points were awarded for that one. Question 4. All right. Let's move on to question 5. It gives you a twice differentiable function f and g. And just to refresh your memory, twice differentiable means the first and second derivative exists everywhere. Twice differentiable function f and g are given, and selected values are given. Find the x coordinate of each relative minimum on the interval negative 2 to 3. Okay, so we know a relative minimum occurs where its derivative of a changes from negative to positive. So I want to look at the derivative of f. When is the derivative of f change from negative to positive? That would be at 1. So f has relative minimum at 1 because f prime of 1 is 0, and f changes, oh, sorry, mistake there. It's supposed to be f prime. F prime changes from negative to positive at x equal 1. All right, part B. Explain why there must be a value between a1 so that the second derivative equals 0. Another existence theorem. This one's the mean value theorem. How do I know that? Because I'm talking about the slope or the derivative of the interval. But since I'm using the second derivative, that means I want to look at the slope of the first derivative. Okay, so I want to talk about f prime here. So first you have to say that f prime is both differentiable and continuous on -1 to 1. And again, I know that because I'm told it's differentiable, and differentiability implies continuity. And then find the slope of f prime. No, notice, not f, the slope of f prime from -1 to 1. Show that slope is 0. And then um, by the mean value theorem, there must be at least one c between -1 and 1, such that the derivative of f prime or f double prime of c must be 0. And that's the mean value theorem. Okay. C gives you another function. H of x is ln of f of x. Find h prime of 3. Okay, just another derivative. So use the chain rule once again. The derivative ln of u is 1 over u times du. So 1 over f of x times f prime of x. And then just plug in 3. It's 1 over f of 3 times f prime of 3. Just get these numbers from the table, and it's 1/14. Okay, that hopefully was pretty easy. Um, D, evaluate this integral. Okay, this is going to require substitution, right? Because I've got a function g inside the function f prime. Okay, so um, now make sure when you do substitution with a definite integral, don't forget to not just find u and du, but you have to change these limits of integration from x values to u values, all right? When I saw your work, many of you did the substitution, but you forgot to change the -2 and the 3, okay? So u is g, du is g prime, and then from the table, g of -2 is -1, g of 3 is 1. So then this becomes the integral from -1 to 1 of f prime of u du. That's what it looks like after you do the substitution, integral -1 to 1. And then just do the fundamental theorem of calculus. Antiderivative of f prime is f, plug in 1, plug in -1, subtract, and you get -6. All right, so um, let's look at the scoring guidelines for that one. Uh, A was 1 point, answer with justification. Notice, just the answer itself gets 0 points. You must have correct justification to get the points for A. So you had to say that f prime changes from negative to positive. Um, and B, um, 2 points. 1 point for showing that the slope was 0 of f prime between -1 and 1. Point for showing that slope was 0. And then 1 point for the explanation using the mean value theorem. Okay, so um, it doesn't have to be written out exactly like it says here, exactly like I wrote it, but you had to state that f prime was differentiable and also continuous. Um, and C, 3 points. 2 points for doing the derivative, and then 1 point for plugging in the numbers and getting an answer of 1/14. And then D, 3 points there. 2 points for the fundamental theorem of calculus. In other words, that's the u substitution, the u and the du, and doing the antiderivative. All right, and then 1 point for the final answer. Okay, so let's say, just as example, let's say you did u is g and d is g prime. Let's say you did all that, but you forgot to change the -2 and the 3 to 1 and -1. Then you would have got 1 point. You probably would have got 1 out of the 2 points here, but you would not have gotten the answer point because your answer would have been wrong. Okay, so you would have got 1 out of the 3 points if you did that. Okay, um, let's say that you did wrote it out right and did the one play wrote it in terms of 1 and -1, but you just plugged the numbers wrong and your answer was wrong, then you would have got 2 out of the 3 points. Okay, and if you got to -6 and showed your work correctly, you got all 3 points. Okay, so that was question 5. One more to go here. Okay. Um, Last one gives you a differential equation. Okay, wants you to gives you a slope field. Draw the Schuchen curve through the point 0, 1. I'm just going to go to the scoring guideline for this one. I didn't draw it out myself on paper. I wanted to use the slopes there, but there you go. Just follow the slopes and 1 point there. Okay, not too much. All right. 2, write an equation of the tangent line through the point 0, 1. Use that equation to approximate f of point 2. All right, so tangent line, we've seen that many times before. You know what to do. A slope and comes from the derivative. So you're given the point 0, 1. Plug in 0, 1 into the dy dx that's given to find your slope. So dy dx is 2. That is the slope. And then You got a slope and a point, write your tangent line. All right, now use that to approximate f of 0.2. So just plug in 0.2 for x, and you get 1.4. Okay, hopefully a couple easy points there. And then last part, find the particular solution to the differential equation using the initial condition. All right, so that's what we talked about a lot on our last progress check, solving a differential equation, okay? That's the separation of variables. All right, so this is, we're 6 total points. You'll see when we're done, a lot of points here. So as I said before, even if you don't get all the way to the end, you should be able to get most of these points. So step 1, separate the variables, separate the y's and x's. Okay. Step 2, integrate both sides. All right. Left side becomes ln of absolute value 3 minus y, but don't forget, because of the minus y, you need a negative out in front. Okay, that's the left side. The right side, Andrew, of cosine x is sine x, and then put your plus c. All right. And then what do you do next? Plug in 0, 1 to solve for c. So we do that, and you get c is negative ln of 2. All right. And then you plug that back in here. And then the last thing is your algebra to solve for y. So first thing I did is multiply both sides by -1 to get rid of that minus out in front. Okay. And then I get rid of the ln by raising both sides to the e. So absolute value 3 minus y is e to this. Now remember I mentioned before, if you're adding in the exponent, you multiply the bases, okay? So this becomes times e to the ln of 2, which is 2. But it's not plus 2. Do not write that as plus 2. It's times 2. Or if you didn't want to worry about getting that wrong, you can leave it like this. You don't have to simplify that. So you can leave it like this. That is okay. All right, but don't put plus 2. It's times 2. Now, what about the absolute value? Well, look at my answer. I want, when I plug in 0, I want to get 1, okay? So since y is less than 3, right, then plug in 1 for y, this will be positive, so I can drop the absolute value and leave it positive, okay? So I can, if that was like bigger than 3 and 3 minus y would be negative, then you'd have to put a negative out in front, okay? But in this case, it's positive. And the last step then is to just get y by itself. So add the y, subtract that, and you get 3 minus 2 e to the negative sine x is your final answer. All right, so let's check where all those points come from. All right, as I said before, 1 point for part A, okay, 2 points for part B, all right, 1 point for the tangent line, and then 1 point for plugging in 0.2 and getting the approximation of 1.4. And then that means part C is 6 points. 6 points, check all this. 1 point just for separating the variables. You do that, you get 1 point. 2 points for the antiderivatives, 1 for the left, 1 for the right. All right. 1 point for putting the plus c, the constant of integration. 1 point for plugging in your 0, 1 to solve for c. All right, and then the last point is the solving for y. Okay. Notice if you don't separate the variables, you get 0 points. Doesn't matter what else you did. Or if you don't separate the variables correctly, you get no points. Doesn't matter what else you did. So you have to separate the variables first. And if you don't put the plus c, the max is 3 points because everything else, the initial conditions, however, why you need that c in there. Okay, so max of 3 points if you don't put the plus c. Okay, so that's how that is distributed. All right, real quick before I finish, I forgot to have this handy before, but I want to show you this now that we're done. I want to show you the scoring averages for these problems. Now, these problems I gave you were from the 2014 AP exam. So if any of you have any older siblings who happen to take AP Calculus in 2014, those are the problems that they took on the exam. But I want you to see the mean or the average score, okay? Remember, each of these are worth 9 points. As I've been telling you, if you can consistently get 4 or 5 points on there, you're doing pretty good, okay? And hopefully on a couple of those, you get even more than that, okay? But check out the mean. On number 1, 2.5, that's the average. So you only have to get a couple of parts, a couple, like each of those parts, 1, 2, sometimes 3 points. But if you get a couple points here, a couple points there, you're doing above average, all right? Question 3, 3.26. Question 4, 2.64. Question 5, 3.62, and question 6, 3.92. That was the highest scoring one. The slope field was easy to draw, and those differential equations, there's always a couple easy points there. Okay, so that's always one of the higher scoring. But you can see here that the average is between 2.5 and 3.9. Okay, so if you can average, like I said before, 4 or 5, you're doing really good. You're doing above average. If you can average, 6, then that's really great. That's like 5 material, okay? If you can average 3 or 4, then you're have a decent chance of getting a 3, okay? So uh, that's and again, your scoring breakdowns will be different for your test this year because it's not formatted the same. But I can expect sort of the difficulty probably to be similar, okay, as far as how those are scored. So that's what I'm really focusing on with these kind of problems. I want to make sure that you get the points you know how to get, where you can get them, okay? Don't worry about the really challenging parts. Um, some of you can get them, right? Those of you that want to get a 5, I know you can get those, all right? But the points that are easy, the points you should be able to do, that's what I want to focus on you getting, okay? So look those over, look at what you did, and score your own work. And we'll be doing this again with the future problems. And hopefully, each time we do these, you get a little better with your scoring as you become more familiar with these problems.